Hello students, how are you? I am Tejesh from 2Pi Academy. Today's video is about matrices. Matrices are one of the most powerful tools in mathematics. They are used in various fields where you need to do large amounts of computations like in budgeting, sales forecasting, cryptography and many more. First, let's take a small example to understand matrices. Imagine there are 3 students ABC in a school and they have taken 2 tests, maths and physics, and out of the 100 marks, the following are the scores each student got in each of the subject. Now we will try to represent this as a matrix. To do that, first you have to draw 2 large rectangular brackets and fill the numbers inside this in the form of rows and columns. For example, in this case there are 3 rows and 2 columns, right? Now here, if you observe carefully, each row represents a student. The first row represents the first student, A, and the second row represents B, and the third row represents C. Similarly, the first column represents maths, and the second column represents physics. You can also represent this in another way as the following. In this case, the rows represent the subject. The first row represents maths, and the second row represents physics. And the columns represent the students. The first column represents A, second column represents B, and third column represents C. Now let's first try to define a matrix. A matrix is nothing but a rectangular array of numbers or functions. Rectangular array means that it consists of rows and columns. And matrices are denoted by capital letters. Now let's see some examples. Here A is a matrix. And as we have said before, it is denoted by capital letter A. And the elements are arranged in rows and columns. 1, 5 and 0 are in the first row, -8, 4, -2 in the second row, and 3, 0, √5 in the third row. And there are also 3 columns. 1, -8, 3 in the first column, 5, 4, 0 in the second column, and 0, -2, √5 in the third column. And here the numbers can be any type of numbers like the integers, rational numbers, irrational numbers, etc. And B is also another matrix. And once again, it is also represented by capital letter B. And this matrix consists of 3 rows and 2 columns. The numbers present inside a matrix are called as the elements of the matrix. Like for example here 5 is an element of A. Similarly 1/2 is an element of B. And one thing to remember about matrices is the order of a matrix. If a matrix have m rows and n columns, then the order is nothing but m by n. Please note that this is read as m by n and not m into n. Here for example, A have 3 rows and 3 columns, right? So what is its order? It's 3 by 3, right? And we will call A as a 3 by 3 matrix. Similarly, B have 3 rows and 2 columns. So its order is 3 by 2, right? So B is a 3 by 2 matrix. Now the general representation of a matrix. Suppose A is a m by n matrix, which means that it have m rows and n columns, right? Then A can be represented as the following. Here if you observe carefully, there are m rows and n columns, right? And each element is represented by the general term Aij, where I denotes the row number and j denotes the column number. Like for example, A11 is present in the first row, first column. Similarly, A12 is present in the first row, second column. And AM3 is present in the mth row and third column. And generally, Aij is present in ith row and jth column. Simple, right? And one thing you have to remember is, in a m by n matrix, the total number of elements is m into n. There are m rows and n columns, right? So total will be number of rows into number of columns, that is m into n. Before continuing the video, please subscribe to the channel and hit the bell icon so that you can get notified for every future upload. Now let's try solving some examples. In the matrix A is equal to 2, -1, 0, -2, 1, 0, write the order of the matrix, the number of elements, and write the elements A12, A31, A22 and A32. Now here order is nothing but number of rows by number of columns, right? And in this example there are 3 rows, 2 -1, 0 -2 and 1 0. And there are 2 columns, 2 0 1, -1 -2 0. So therefore the order is nothing but 3 by 2. Number of rows by number of columns. And the number of elements, you can simply count this and get the total value of 6. But it is better to use a formula, right? Number of elements is nothing but number of rows into number of columns. And here there are 3 rows and 2 columns. So 3 into 2, which gives us 6. And now the elements A12, A31, A22 and A32. Now here in this matrix, 2 is the first row first element A11 and minus 1 is the first row second element A12 and the element at second row first column is 0. Second row second column is minus 1. The element at third row first column is 1 and finally the element at third row second column is 0, right? Now here A12 is nothing but the element in the first row second column, right? Aij means I denotes the row and j denotes the column. So in this case, it is in the first row second column. So therefore it is minus 1. A31, 3 means the third row and 1 means the first column. So third row first column, which is nothing but 1, right? And A22, once again, the first 2 represents the row and the second 2 represents the column. So it is second row second column, which is nothing but minus 2, right? And finally A32, once again the first number denotes the row and second number denotes the column. Third row second column, which is nothing but 0, right? Construct a 2 by 3 matrix A is equal to Aij m by n, whose elements are given by Aij is equal to I by j. So now A is a 2 by 3 matrix, which means that it have 2 rows and 3 columns as the following, right? And the element in the first row and first column is A11, first row second column is A12, first row third column A13, and second row first column is A21, second row second column A22, and finally second row third column is A23. This is the general representation. Now we just have to calculate each of the element one by one. So first, A11, by substituting I and j in this we get 1 by 1, which is nothing but 1, right? And A12, I is 1 and j is 2. Substituting in this we get 1 by 2. And then A13, once again the first number is I and second number is j. Substituting in this you get 1 by 3, right? And then A21, I is nothing but 2 and j is nothing but 1. Substituting we get 2 by 1 or 2. And then A22, I is 2 and j is also 2. Substituting in this we get 2 by 2, which is nothing but 1. And finally A23, I is nothing but 2 and j is nothing but 3. Substituting in this we get 2 by 3. So therefore our required matrix A is nothing but 1, 1 by 2, 1 by 3, 2, 1, 2 by 3. If a matrix have 12 elements, what are the possible orders it can have? Now the number of elements is nothing but number of rows into number of columns, right? So we just have to find number of rows into number of columns such that their product is 12. So the possible orders will be 1 by 12 and 12 by 1. In both of these cases product is 12, right? And 2 by 6 and 6 by 2. Once again here also the product is 12. Or 3 by 4 and 4 by 3. In all these 6 cases the product will be 12. Therefore the number of elements are 12.